There we go. Hey, everybody. Welcome to Astronomy Daily Live. This is where we gather together practically each and every day and just, think and talk all kinds of astronomical things for about an hour, sometimes a little bit more, sometimes a little bit less. Usually try to keep it to about an hour or so, just to shoot the breeze, see what's happening in the astronomical world and the space world, and at least those two main areas. But those are extremely broad areas, so tangents are allowed as well. So cool. Yeah, come on in, everyone. Now, I am seeing a well-lit Bobby on the panel. Hey.
Hey, good to see you, Cosmic. Yep.
Right. Yeah. Good to see.
3 of those track lights are LED style for about $8 at your local Walmart. And what's also good about it, you actually do need 2 out of 3, and it's written like a son of a gun.
It is. It's like the sun. Yeah. So that's absolutely great. Nice to see you there. And Tom is on the panel as well. Hey, Tom.
Hey guys, how's it going?
Going well. Cheers.
Cheers.
Yep. About water.
All right, so we'll let people drift in. I'll tell you the story of last night's epic failure once again. I'm not quite sure what's going on with that, but I didn't think that I was going to actually reach my dew point until much later in the evening. I was expecting, 1 or 2 in the morning, and by then I'd be long done, right? I figured I had easy until 10 o'clock. Easy. No problem. 10:30, no problem at all. And so I get out there, okay, and I've got to take my calibration data first, right, as the sun sets. Right after the sun sets is when you take your calibration data. At least the way, that's the way I'm doing it. So I took everything out and set everything up, got the camera cooled down, everything else, and looked at the time, and it was about, local time, it was about, I think I want to say maybe about 5:15. Okay, 5:15 or so. Sun had gone down, at least behind these nearby mountains here, maybe 15 minutes before or so. I could still see sunlight on the mountains to my east. So, waited at least until the sunlight was off of that. So it was about 5:15 or so. And I'm like, I wonder when I should get started. And so what I did, which I thought was, moderately logical, was I looked at the timestamp on the calibration data that I had taken, 3 or 4 days ago? I'm not exactly sure. Yeah, maybe 4 days ago. I don't know. And the first calibration image I took was at 5:34. So I'm like, oh, okay. I can probably start about then, because it's only a few days. Darkness isn't going to change that much, is it? And so it's like, okay, I'll just sort of hang, this way. I'll be absolutely certain that the camera is both cool and stable, right? So if you sort of plot the camera temperature versus time, as it cools, right, it sort of does a decaying sinusoidal kind of a thing, right? So, you know, it drops, but it shoots too low, and so it tries compensating, and you know, it's just this damped motion, right? And so it takes about maybe 5 minutes or so for that to, you know, stabilize, so it's not wobbling around or something. So it was 5:15. I figured I had till 5:34, you know, 5:30 at least. So it's like, oh, okay, cool. You know, I got 15 minutes. So, you know, came back inside, piddled around a little bit, went out at 5:30. It was actually a little bit before that. It was like 5:28, and I look over at the sky over there, and it's really dark. it's yeah, it was really dark. And so, you know, got on the flats, had to take 5-second flats, 10-second flats, and 15-second flats, and I got 10 5-second flats, 10 10-second flats, and only 5 15-second flats, because it was just getting dark. It was way too dark. So my calibration data was definitely not ideal, right? I mean, it was adequate, but you know, definitely not ideal. The other days ones, that was probably the best calibration data I've ever taken, and it's absolutely, well, it's not exactly useless, but I mean, it's this close to useless. So it's like, right? So, you know, the start of last night was sort of a downer, right? Because it's like, well, you know, the calibration data is just sort of, okay, you know, marginal. You know, doing, right? So, um, cool, you know, sort of, you know, carved out this extra block of time. So I'm going to take that time and sort of investigate how well this thing points, depending on the alignment I do, and because my experience has been is that it's pointing isn't incredibly good, but it changes. It changes every single time, which means the star alignment is either really good or really bad, you know, for whatever reason. And so, you know, what I'm trying to do is come up with a methodology of sort of ensuring that my pointing is at least going to be consistent, right? I mean, even if it doesn't, you know, point exactly to my target, if it's always consistently off, you know, by a certain amount, that's fine with me. I don't care. If it just so happens to point exactly at my target, that's even better. That's what I was investigating first, and it was actually really nice to have that block of time to be able to do that, because I was waiting for it to get dark, and it's like, you know, what you gonna do, you know, for that amount of time. So it's like, yeah, that was a good exercise. I actually ended up only doing one alignment, because that first one I did, for some reason, had all the magic in it, and my pointing was absolutely spectacular. I was actually getting my targets in that little tiny field of view, uh, which was amazing, right? I did the alignment on Altair and uh, and Vega, right? So both over in the west. And for some reason, as I said, there was some kind of magic something. And everywhere I pointed, I told it to go to Mars, and Mars wasn't exactly centered, but it was in the field of view. And then it's like, okay, let's go over to Capella, right, which is on the complete opposite side of the sky. And it got right there, and Capella was in that tiny, narrow window. So, somehow, amazingly enough, it seems as though the pointing was really, really great. So, I experimented, I tested this on several other stars, lots of other stars, that I could actually see, right? So, with every single star, it's like, well, this thing seems to be, when I tell it to go to a certain star, right, it's going to a certain right ascension and declination in the sky. And when it goes to where it thinks that star is, it certainly is. So, yeah, lots of confidence there, right? So great, right? So now I have to wait a little bit because my targets are still a little bit low, right? So I have to wait. I don't know. I think I waited maybe half an hour or so. So yeah, it's probably around, I don't know, 7:30 by now, something like that. 7:30 local time. So at that point, I go back out, and yes, indeed, the my first target is high enough above everything that the telescope should be pointing right at it, right? So I left the telescope looking at it, and it basically should be tracking. So just in case, retyped in a right ascension, retyped in the declination of the first star, and went to that star, and I, so I made up these charts, right? These finder charts, so I could have that out there with me. I could look at my little field of view, look at the chart, and compare stars, right? It's like, okay, there's that one, and that one, and there, there's that, there's that, there's that. So once I could identify them on the chart, then even if I'm off with the pointing, I'd be able to star hop to my target, right? Sounds easy, right? And no, for the next I don't know how long, I kept staring and staring and staring at the computer screen and my chart, trying this to see the pattern of stars on my chart that I was seeing on my screen, and I absolutely did not at all. And I've gotten really, really good at doing that. So I mean, I can usually find a pattern like this, especially, right? In very, very busy plots like that. I can usually find patterns really, really well because I've just been doing it for so long. So to not be able to do it, yeah, it was absolutely have idea at all. Uh, so yeah, I'm going to have to investigate that a little bit. I did take a little data. Um, so, I do have some examples that I can look at. Um, but yeah, I I think probably my telescope actually started to do up probably a lot earlier than what I thought, because that's you know once I was working on this a little while, trying to find these patterns. I realized that the notebook that I had out there was feeling a little damp, and so yeah, I started looking around and noticed condensation on like the computer screen and on the computer itself, and I'm like, this is probably not very good. It's so incredibly rare that we have. I was saying, right at the beginning, it was so rare that we actually reached the dew point that early in the evening. It usually comes much later, like 1 or 2 or 3 in the morning, as opposed to 8. Yeah. So yeah, I at that point, I'd sort of, pretty much threw my hands up in the air with trying to find, these similar patterns, and then when I saw my the front glass plate here, just like completely in a fog, just totally fogged over. It's like, okay, yeah, this one is over. So yeah, it's beat again, and hauling all this in last night. Thought is, it's like, man, this is really hard. Do I want to do this or not? So yeah, a little bit of discouragement, but yeah, got up this morning and it's like, how am I going to solve this problem? so yeah, a little bit of excitement.
Well, it's too bad it didn't work out. Sounds to me like you just need to find another night and hope that the humidity stays away a little longer.
Yeah. I like I said, I want to look at my my charts again, because what I was seeing was a pretty bright star right next to it. Right next to it was another relatively bright star, and there were a couple other stars, at least on the screen, down to my lower left, like over here, right? So I had 2 bright stars here, 2 faints here. That's a good pattern, right? I mean, it's an easy one you have to sort of see on a chart. And nowhere in a 2-degree radius of view did I see that pattern at all. So yeah, I'm going to have to look and see, because it's possible that I actually overplotted a bright star over a nearby faint star. That's a possibility. So yeah, I just have to look in a little bit and yeah, get to the bottom of it. This is definitely not an impossible task. And difficult tasks, they're difficult at first, and then after you do them a while, it's really, really easy. So
I
hard
cannot
sensitive
believe
game.
the humidity beat the crap out of you.
Yeah, it's well, like I said, I mean that happens out here, this time of year, right? Wake up in the morning and everything's frosty, right?
Yeah.
But
And 9-inch Coast to join in says saw a video game you might be interested in called Signal Simulator.
Signal Simulator. Okay. Huh. It's if I were to Google that, I probably would find something. We can I can investigate this later, but let me at least put it somewhere where I can find it. Unite Colas. Everything is well where you are. All is good here.
Well, that game does look interesting. It says it's a SETI simulator.
Cool. Interesting. All right. Well, I will definitely have to check that out. I'm I don't know exactly why, but I've never really been into games. Not really. I mean, yeah, just I mean, and maybe I can get everybody's opinion about this. My favorite really is pinball. That's there aren't very many things that I would like actually want.
Oh my gosh.
A nice pinball machine from the 70s or so, the old style ones. Tick 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 tick. Yeah. Yeah.
Oh man, pinball was the bomb. I even had like a little pinball game that I used to have and stuff. That was pretty darn cool.
There was one, Bob, I can send you if you've never seen it. I'll send you some information about it. I don't know exactly what it was called, but
It's like arcade style.
this is an arcade pinball game. But this one, the floor, the entire floor was curved, right? And instead of curves, that pushed balls like out, they were all rotating bumpers, spinning really, really, really fast, and so it was just absolutely crazy pinball game. But yeah, get me a pinball game from like the 70s. The old clunky things, with the bills and everything. Yeah.
I don't think I do to think if you don't like pinball, then you got yourself a problem.
we spent way too many hours. Way too many hours. We at least I think it was just we in high school, I think juniors and seniors were allowed off like during lunch and stuff. So to the little 7-Eleven, and they had 2 pinball machines there. And so I mean, we were just done, right? I mean, I was great. It was absolutely great. But I'm trying to think of electronic video games that like arcade style. I like Centipede. Centipede was good.
Space Invaders. No?
Space Invaders, sort of. Yeah. I mean, they're a classic for sure.
My instructor for Bowtech used to play Double Dragon every single day and beat the crap out of that game.
That's great. Yeah. To play Stargate. Remember Stargate? I played Pac-Man and Oh, and yeah, you know,
Yeah,
I don't know,
Batman can be a son of a gun sometimes.
but you know,
So is Donkey Kong.
yeah, and uh, anything does
You
that?
know, Walmart right now you can get one that's like one of those arcade things,
Uh-huh.
and I'm not sure how much the price though.
Yeah. Well, it's nothing like the real thing though. Regardless, asteroids. Remember asteroids? That was pretty intense. Yeah.
Asteroids. Oh my gosh. I think
Yeah.
I can be a badass with asteroids and centipede.
Asteroids was good. There was another one called Galaga. I used to play that one. It
Okay.
was kind of
Yeah.
like Space Invaders.
Galactica and Galaxian was pretty darn good.
Yeah.
That we sort of like to play. It was actually based on Tron. Did you ever play Tron? That was kind of an interesting one.
Not familiar with that one.
Okay. Yeah. Yeah. Played that a lot, but
I
no.
remember when my Walmart once did have an arcade before they changed it to a money center.
Oh yeah. Yeah. No. But
I used to play skee ball, and there was a game called Crazy Taxi. I was a good one on Crazy Taxi.
huh.
But I could be all right with cruising in Sonico or cruising USA.
Yeah. I I have not played pinball in years. Yeah.
And speaking of cruising USA, I had a Nintendo 64 game, and I beat that game.
Wow. What happens when you eat it? What does that mean?
Well, you just don't get a cake by the ocean, though.
Okay. Yeah. Yeah. But yeah, and then I wasn't paying attention, but I've shown you this before. I should drag it out again. But my first computer was a Timex Sinclair ZX81, and it had 1K of memory. And when you turned it on, it gave you a little black prompt way down here in the corner, right there, and that's it. And what you did is you started writing a program, BASIC. So to get this to anything at all, anything, you had to tell it, right from the beginning, uh, what you wanted
Now,
to do.
they can also can do blackjack.
The what?
Now, I wonder if that time at Sinclair computer can do blackjack.
I imagine it probably could, but probably not with K. You probably couldn't make anything that's that small. But with the 16K expansion board, right, which you slipped onto the back and hoped, crossed finger, right, that it didn't move in the wrong way and lose contact, right? Because if you lose contact, you lose your, right? And so, the trick was type on this thing and not have it move at all, which is a difficult task.
Now, I'm about to ask, did you ever have an Apple II?
I did absolutely not. No, that was way out of my price range. Way out of my.
My elementary school had an Apple II.
Oh, cool. Yeah.
And those Apple II machines, they're pretty darn good with those games and stuff they made for it.
My high school had TRS-80s, track 80s. Remember those things?
No, I don't.
Tom does.
Yeah, I remember them. I didn't play with too many of them, but knew a lot of people that had them.
Yeah, those are great. I think they.
You know, if you look at Bill's retro gaming channel,
Uh-huh.
he had like the Atari. I forgot what Atari it was called, but he has also have a Commodore something.
Cool, cool. Yeah,
No,
I
the
want.
Amiga 500.
Oh, okay, I got you. Yeah, choice between getting a Commodore 64 and a X28, which had 72 of memory. And I thought, well, Timex Sinclair has done me well, and it's really more than the Commodore. so, so I got that instead. So actually, I don't think I've ever owned an Apple anything. Can't think of one thing of Apple's that I've actually owned. Don't have an
I
iPhone.
had someone gave me a Power Mac G3, older model of a Power Mac G3.
Okay. Now, I in terms of owning Macs, no, never, ever, ever have. Worked with Macs, yes, yeah. So yeah, in terms of
I worked
owning,
with Macs too when I was in Botech. Those deals, iMacs with Weapon or Snow Leopard, those were pretty darn good.
cool.
I
Yeah,
never went higher than that ever after I left Botech.
cool. All right. Well, how do we get to that? Anyway, so yeah, so that's what's
And you're
going
starting
on.
to laugh too.
Lagging a little bit. Right.
Yeah.
Let me. I'm not. I'm pretty sure. I close things down here. So yeah, I did. Let me close that window. That's about as minimalistic as I want to be. So let's see. I need to look at the chat here too. Okay, see now, Bobby, the Nightbot responded to you. So, oh, it's my weather, not just weather. Ah, that's it. I, something about these machines just drive me crazy. Is that they do exactly what we tell them. Cable. Yeah. There we go. So yeah, even now the humidity.
Welcome, Uncle Bill. It's not lag. Sounds like the mic cable again.
All right, I will stop.
I think it's time for you to get yourself another mic.
We'll stop fiddling with the thing. It's probably just hearing me fiddle with it. So all right, well, cool. So yeah, that's sort of an update on the photometry thing. It's like I said last night, everything in. It's sort of like, do I really want to be doing this? Morning. Well, during the night, some during that question was answered. So I woke up, I was already thinking, it's like, what do I need to do to solve this? so, like I said, they're usually really, really hard at the beginning, and then after you do a while, get easier and easier and easier until you even think about it. It's like, that was hard? That wasn't hard. So yeah, I've experienced this so many times, and I don't anticipate this being any different at all. So no worries at all. So let's see. Well, we're still launching rockets, or are we done? Are all four of them up?
No, the ISS supply mission didn't go. Kind of a strange reason. I guess it's not that strange, but part of the cargo was going to be some food for the mice that are on board for experiments. And they found that the food had mold on it. And so they couldn't replace it in time for today's launch. So they're scheduled to go tomorrow.
All right.
But
Wow.
the other one out of...
Okay, go ahead, Tom.
No, I was just going to say the other launch today went successfully. No problems. The one out of French Guiana deployed 2 satellites, and I think everything is working as expected.
Cool.
Yeah. And you need Mama Ata to remind you not to fidget in Space House Hell because the mold of the mouse food. And yes, you win, Tom.
Mold on the mouth.
Oh, well, I didn't have to type anything in, Uncle Bill. I just had to talk, so that's faster response.
Ah, ha, ha. All right. But yeah,
got that pump up kicks. And Ray Rael, welcome. Coming 46P on December 13th. It'll be visible with the naked eye.
Yeah. We forgot to mention that I did look at that comet last night. I've got some 10 by 2 binoculars, so not really, definitely big enough. And yeah, it's a big comet. Yeah, it's pretty impressive. So yeah, pretty cool. It's real fast. So if you want to catch it in sort of the early evening, you're going to have to hurry because yeah, it is going fast, fast. So okay, yeah, and Uncle Bill did do that for us over there. Ray, hey there, Ray, nice to see you. Cheers. Oh, it's there's a good possibility that it is going to be naked eye. I really didn't try to make any kind of estimates or anything. I would have had to sort of know what the magnitudes of the stars were, to make even a guess. So, but it was definitely really big. Again, I don't know what my scale was there. I mean, it was big in the field of view, and round, maybe shaped a little tiny bit. Maybe saw a nucleus, sort of a point right in the middle of that larger coma. Maybe kind of saw some color. It didn't look gray. A lot of times, these things sort of be gray. This seemed to have maybe a little bit of color. Really be sure what color. It definitely wasn't a gray. It was a colored gray of some sort. So yeah. But we've got another. Let's see. I think closest approach happens first, and then perihelion happens like the next day. So, and I think that's coming up on like the 12th and 13th, right? So we've got a few days yet. Oh, I'm almost understandable. Oh, okay. Check the mic. Is it that I'm soft, or am I just breaking up like crazy?
You're sometimes like breaking up.
I'm breaking up. Okay, I'm going to pop this off here. Here, we'll see. We'll see what it does. I just won't so that I've got a thumb drive here I'm just, fiddling with. So
Still fidgeting, aren't you?
fidgety. So yeah, pretty comet. I think I haven't seen it quite a while. In quite a while, I don't remember. Honestly, I don't remember the last comet I ever saw. You know, after Hayakatake, I was just sort of like, I don't need to see any more comets. I've seen the good ones.
Yeah, Uncle Bill Durham, you're still breaking up.
Am I? Oh,
Well, if you could see it with your binoculars, I may have to go out and try and find it the next clear night I get here. It's been snowy
yeah,
the last few.
yeah. It's pretty easy to see. It's you know, it's still pretty diffuse. So what you're looking for, right, is just sort of brightening, right? It'll look like a bright patch of sky, right? So I mean, it's not going to any kind of object. It's a cloud, right? I mean, it's basically a big cloud. So pretty diffuse, right? So it does though, just sort of look like brightening. As you look at it, and definitely this is a great use of the averted vision. Right? So go off to the side, but focus your attention on that patch, and it'll actually pop out even more, and that's just due to the structure of your retina. Our light and dark sensitive parts are called rods. They're extremely sensitive, to light, basically a grayscale, right? But right in our retina, where we always really look, there are more tones there, and they're sensitive to color, less sensitive to brightness. So yeah, go off the side a little bit and concentrate on where you want to look. And faint things oftentimes really surprisingly pop, just like bang. So give it a try. That works with binoculars. I mean, it works with our eye as well. So, all right, well, here's the comet. Yeah, kind of nice to see one. All right, well, cool. Let's I was thinking about Super 1991T. This is the supernova that I and it's been several years since I sort of looked to see if there's anything new about this particular super. Last I saw, and maybe we can remind ourselves here too, was something unusual about it. I don't remember exactly what it was. So I thought that we could go on that little journey here. Let me.
Yeah, you're breaking up, you're going bad as well.
Oh, am I?
Yeah.
He's breaking up, still breaking up. Yeah. Try this. All right. I'm gonna keep going. Ching, 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 ching. go with the panelists? How does it sound?
It's breaking up a little bit to me.
Is it? All right. So it's not like a YouTube thing. It's probably a. Okay. We just got to deal with it, I guess. So I'm just gonna keep here. So I think what I did before is I went over to.
Did anyone hear about the company who will be creating an on-demand artificial video shower?
Yeah, Space TV. Think I think tomorrow PMRO did an interview. I think they're the ones that did an interview with those guys. Is that right? I think it was TMRO.
I heard about it.
News.
Yeah, it's been a while. I heard about it. I don't remember who it is. A Japanese company or something? I don't remember.
Yeah, shoot. It's been too long. Space TV, check out PMO dot. Is it .tv or is it .space? I don't remember. Uncle Bill, you'll probably know.
Yeah. So, well, me and Thomas in the brain, you're in. It's probably cable.
Okay.
I remember our company trying to set us for the Olympics in China.
Yeah.
But
I
it's
forget it.
old news and it's usually meant for the Beijing Summer Games. There's going to be Beijing Summer and then there's going to be a Beijing Winter.
Oh, wow, it's a double, huh?
Yeah.
Wow, cool. How'd they get so lucky? All right, well, cool. Yeah, I'm trying to remember a little bit more about those meteor shower things. I think I might have even talked about it on the live stream. Yeah, we might back to look at the. I haven't actually been doing as good of a job titling all these things lately. To get on that because that's a great archive topics. So, but yeah, I like to be reminded of that at some point. But yeah, let me. I think I'll go over to archive, and we can just search 1990. Oh, well, here we go. I'm gonna share my screen and have to hide that. Go to infinity, and let's take a look. So here we go. 1991. And let's just. How about in the abstracts? Searching. Okay. Wow. So pretty recent. They're talking about overluminous supernova 1991 T-like events. Huh.
Hey, Ray was not going to come by his house for the 2024 solar eclipse.
Oh, I don't know. I don't know what I'm doing for that yet. Yeah.
I want someone to take me to Dallas.
that's coming up pretty soon. It's going to be worth going if you're, relatively close. Well, okay, here we go. So it was 2016. Three-dimensional simulations of gravitationally confined detonations compared to observations of supernova 1991T. Huh. I wonder if Sinbad has. Well, yeah. We're not going to see anything because this supernova was in another galaxy. So we're never going to see any, like nebulosity or anything like that. Peculiar supernova 1991T. So that's 2014. I don't remember when I started looking for this thing. A few years ago. Let's just look for in the title. (14) Cepheid calibration of the peak brightness of supernova 1A. Okay, well, there is, of course, the galaxy that it was in, NGC 4527. I don't recognize this. Maybe this is 2012. I don't know. Let's take a look at the date here because I'm not quite sure what that number means. Oh, it's trying. It says this may take a little time. Here we go. It's 1st of December 2000. Okay. So
not too far from the Carbondale, we get about 2 minutes and 40 seconds totality. 2017 was amazing. Took some great images of it.
Yeah, you guys are getting sort of a double there then. Wow. Very cool.
He's a hit and miss on Friday afternoon, not the best time.
Gotcha. 2 minutes and 40 seconds. That's incredible. All right, yeah, so this is year 2000. I'm not quite sure what the 5 is at the end, but that's December 1st. Okay. Now I get it. Or do I? 11. 4. Yeah, all right. Let's see. The brightness of supernova 1991T and the uniformity of decline rate and color-corrected absolute magnitudes of supernova 1A. Supernova 1991T, Reflections of Past Glory, 1994. Okay. 1,000 days past maximum light. I think that's sort of a common thing that seems to be done, right? Is if they can, they sort of like to look at these things, like way, way, way past, right? I mean, this obviously happened in 1991, and here we are in 1994. So let's see. Same or normal photometric behavior the first 400 days. By 600 days, its decline had slowed. And by 950 days, the supernova brightness was consistent with a constant apparent magnitude of 21.3. So it obviously got really, really, really bright, and then dimmed and dimmed and dimmed and dimmed and dimmed. And at 950, it just stopped dimming. Nebular spectrum was composed of iron and cobalt. Cobalt? I think that's CO. Common to type 1a supernovae. By 750 days, these lines had shifted in wavelength. So the luminosity at 950 days is more than that. I don't know if that's a lot. I'm not quite sure. I don't have a reference. You can look at the luminosity of the sun. Yeah. Solar luminosity. Let's see. This is in watts. I'd have to convert that to ergs per second. I'm not willing to do that at this point. Yeah, I don't even. Yeah, it's in watts. Okay. Well, so I guess we're just going to live in mystery there. I don't know if that's a lot or not. It probably is, but I'm not quite sure. So the rate of decline less than 0.04 magnitudes per 100 days. Yeah, so it's still declining, but just really, it just bottomed out. Huh. Kind of interesting. Brightness. So this was 2000. And I think what I'd like to do is see if HST looked at that galaxy, 4527. So let's try to remember that, and we'll go over and see. Okay, so we present a distance to NGC 4527, the host galaxy of Type 1 supernova 1991 T. So a Type 1A is, I believe, where you have like a binary star system, and one component is a white dwarf star, and the other component, I'm not quite sure if there's anything specific or not, but it's usually like a main sequence star, I believe. And they are close enough to one another such that material from the sequence star actually falls onto the white dwarf, which adds mass. And after a certain amount of mass, the core collapses and it explodes into this Type 1A supernova. So it's pretty spectacular. Let's see. So they talk about distance modulus. We need to get into that a little bit more, because this, and yeah, my apologies. I'm gonna have to look that up to remind myself exactly what that is. But this will be able to tell us how far away this thing is. but I just don't remember how to interpret that. I'll have to remind myself. So, but they are saying it's a relatively short distance. The intrinsic absolute magnitude among 1A supernovae are different. Okay. Their brightness corrected for decline rate and color shows a high degree of uniformity. Okay. Either too bright or too dim, since its high redshift selection effects towards the bright end of the supernovae luminosity distribution are probably present. The apparently over-luminous supernovae are our particular interest. So I guess they're calling this an over-luminous one. Yeah, another more extreme example of over-luminosity supernova 1991T in NGC 4527. Besides allegedly high luminosity, I like that, allegedly, it's also exhibited spectroscopic peculiarities. Suggested that 1991 T was a super Chandrasekhar explosion following the merger of two white dwarfs. Oh, okay. Huh. And yeah, now that I see that, it's like that was the thing that made this kind of interesting, is that it's a white, yeah, but they think it's a white dwarf merger. So that's pretty exciting. Cool. I think I'm not going to get into this too much, I don't think, unless there's some neat pictures. I always like the pictures. Oh, there's some nice pictures, yeah. It sort of looks like might be HST data. I think this is NICMOS 2. So yeah, I'll bet you HST has looked at this thing.
Is that the nickname for the camera? NICMOS 2?
Yeah.
Oh, okay.
Yeah, that's a infrared detector on the HST. Yeah.
Ah, okay. Thanks.
Let's see. Okay. Well, as I said, I don't think I want to get into this too much. Just if there's any pictures or interesting plots, I like to look at those. Nah, I really don't see anything. So let's see. NGC 4527. Let's go over and see if there's anything. I'm certain there is. I mean, we already know that there is NICMOS data, but the other stuff too. Let's find out. Go. Oh, what? No, that's not true. 472? Isn't that it? 4527. See? See how you are?
Dang it, dang it, dang it, dang it, dang it.
Dang it, dang it, dang it, dang it. All right, here we go. All right, cross your fingers. Here we go. There we go. That's a little better. Man. Made me sweat there for a minute. So STIS is spectrograph. So let's not do that. Let's sort this by time, though. So we get the latest stuff up front. So the Wide Field Camera 3 back in 2013 Looks like it's got a couple of different wavelengths here. I think these are old enough. They might even be available. Oh, so there it is down there. At least the galaxy, right? Pretty cool. I don't remember exactly where 91T was. I think it was on one of the edges. You know, we should pull this this galaxy up so you can sort of see what we're working with here. 4527. There it is. Zoom out a little bit. It's a pretty one. And as I recall, 91T, come on, 91T was either here or here. But yeah, I can't. Of course, I can't be certain. But nice spiral galaxy, really nice. Seen, you know, not exactly edge on, sort of at a little bit of an angle here. So, you know, this is just one region. Let's see if we can. You see this triangle here? I always see triangles. You see that triangle anywhere? Oh, maybe here, this triangle, and then that sort of points up to this stuff. Maybe. Yeah, I don't know. Yeah, I think so. See how this one goes right through there and goes to there. Let's see. Oh yeah, look at that point. Yeah, okay, so this triangle and this stuff is this triangle and this stuff. Cool. Okay. So now we know that we're looking over here. That's pretty cool. So that was 179 second exposure at 5884. So let's look at a 956 second exposure. Ooh. Oh, okay. It's a smaller image, but that's pretty nice looking though. Pretty amazing. Most of what we're seeing here, right, is stars too, right? All this fuzz. So that's pretty awesome. Oh, okay, yeah. Something about a subway, it looks like here. So these are going to be smaller. Still pretty nice looking though. It's nice not having an atmosphere. Oh look, they actually imaged so-called 1991T back in 2006. ACS. Well, let's see if it's an image. Oh, it is. It's a small one again. So I guess 1991T is in there somewhere. I have no idea which one it is. We'd have to, which we can do. 10607. Let's see. Related to proposal ID. Okay. Yeah, I'm not quite sure if that's going to give us what we want or not. Hoping to maybe see if we could find a paper that showed that picture and an arrow showing showing where the supernova was. But yeah, I don't think we're going to get that lucky. Okay, let's see. Let's move down here. So this was 2006. I think this is all the same. Okay, all this is the same, but Here, we're down towards the bottom. Okay, we're getting into 2002. Still looking at 1991T. I have absolutely no idea if that's it or not. Might just be a field star or something else. Don't know. It was a long. Well, yeah, that wasn't incredibly long. Is this one? No, that's the first one. Here, well, this one's a little bit long. Pretty much the same looking thing. Starting to see a little bit of stuff here, but I don't know if that's it or not. I kind of doubt it, but STIS, that's spectra again. No harm in looking at one. Oh, it's not. Isn't STIS? Isn't that the spectra? Oh man, I'm totally misleading you guys. So yeah, I don't know if that's it or not. I mean, it's right in the middle. It's kind of hard to believe that you'd be able to see it after this many years. But it's a nice cluster here. Look at that. Cool. All right. Well, let's see. We're getting back into 457. I could have sworn that STI was a spectrograph. Huh. Shows how much I know. Yeah, see? Well, that's a spectrum. STIS. STIS. Oh, it's, well, yeah. I don't know. All right, well, cool. I think it's about time that we get on out of here for today. It's always nice to sort of reminisce about things observed in the past. So very cool. Everybody, I'm going to get out of here. Check the chat one more time. Yeah, cool. Nice. All right. Yep, I think I'm going to get out of here. So thanks, everybody, for coming in again. So, yeah, it's been great. I will definitely be here again tomorrow, same time, same place, 2 hours UTC. So, all right, everybody, we'll have a great evening, a great day, and one more spin around, and we'll be back. Take care, everybody. Bye.